See, till 9th and 10th, we used to study about 4 shells, K, L, M, N. Now you got the answer? How many
Yes.
shells we studied till 9th and 10th? 4 shells. But in total, till now, 7 shells have been discovered.
Okay.
Okay. In 11th and 12th class, we don't name them as K, L, M, and OPQ. Instead, we write them as first shell, second shell, third shell, fourth, fifth, sixth, and seventh shell. Got it, Vita? Now
Yeah.
I asked you the subatomic particles. Do you understand the word subatomic particles, and can you name them,
Yeah.
please?
The
Name.
proton, electron, and the neutrons.
Okay. Only 3 subatomic particles are there, or do you think more are there?
Like the ones I know of are 3.
Okay. See, till now, more than 35 subatomic particles have been discovered, Beta. More than 35. But the 3 major ones are electrons, protons, and neutrons. So we would be studying about them only majorly.
Okay.
Apart from them, like neutrinos, positrons, there are many of them. We're not studying them.
Okay.
Okay, but you should know that more than 35 subatomic particles have been discovered. You should know this much only.
Okay.
Got it? Fine.
Yeah.
Now, next page. Give me a minute. Yes. Students know how to relate the position of an element in their periodic table to its atomic number, atomic mass. You know this?
Yes.
If I ask you an element like potassium, its atomic number is 19 and mass number is 39. Now tell me its position in the periodic table. Can you do that for me, please?
Yeah.
Please tell me which group, which period, and how did you found that? If you don't know, just let me know so that we can continue further instead of wasting time.
Yeah, I don't know. It's in the group 1, right?
Yeah, it's in the group 1. See, always whenever you need to find the position of an element, just write down the electronic configuration. I told you the atomic number of potassium is 19. So can you tell me the electronic configuration of potassium then?
Sorry, the
Electronic configuration of potassium. Can you tell me that?
yeah.
Please. Tell me the electronic configuration, please.
It's
First shell contains how many electrons maximum, Beta?
first shell contains 2.
2. So out of 19, 2 came in the first shell. Second shell contains how much?
8.
8. So 2, 8 is done. 10 are over. Rest are 9. So third shell would contain how many electrons in potassium, Beta?
8.
8. And the fourth shell?
1.
1. So the configuration becomes 2, 8, 8, 1. Done?
Yeah.
Okay. How many shells you wrote? 4, 2, 8, 8, 1 means 4 shells.
Yeah.
So it belongs to fourth period.
Oh.
Okay. As many number of shells are there, that would be the period. If suppose there are 2 shells, like for example, let's take oxygen. Atomic number is 8. So configuration becomes 2, 6. Now there are 2 shells only. So its period number is 2. Got it, Beta?
Yeah.
Yeah. And how to find the group number? If the last shell contains 1 or 2 electrons, the group number is the same. The last shell here, it was containing 1 electron, so 2, 8, 8, 1. So that is why group 1.
Yeah.
If the last shell contains 3 to 8 electrons, then you would add 10 and tell me the group number. Let's say oxygen, I was telling you. So the configuration was 2, 6. So the last shell contains 6 electrons.
Yeah.
You would add 10 and tell me the group number is 16. Got it, Beta?
Yeah.
Okay. So that is, you can relate the position of an element in the periodic table to its atomic number and atomic mass. And you should know, you must be knowing that the nucleus of the atom is much smaller than the atom, yet It is the most heaviest part of the element of the atom.
Yeah.
You know this now?
Yes.
Okay, out of electron, proton, and neutron, can you make a guess which one is the heaviest subatomic particle and which one is the lightest?
The heaviest is the neutron.
Okay, and lightest?
The lightest is the electron.
Okay, and for your surprise, protons and neutrons have equal weight. So protons and neutrons both are heaviest and electrons are lightest.
Okay.
Okay, beta?
Yeah.
That is why we say the whole of the mass of the atom is concentrated in the nucleus. Why? Because it contains protons and neutrons and both have equal mass. That makes your nucleus heavy.
Yeah.
Clear? Now let's come to modern atomic theory. Okay.
Yeah.
All matter is composed of atoms. Our modern atomic theory states that all the matter is composed of atoms, including us also. We are also made up of atoms. Atoms cannot be subdivided or created or destroyed in ordinary chemical reactions. However, these changes can occur in nuclear reactions. It means your nucleus, you cannot divide the nucleus or create a nucleus or destroy a nucleus in ordinary chemical reactions in the laboratory, but in nuclear reactions, this happens.
Yeah.
Okay, understood this line?
Yes.
If there's any doubt, no, you can stop at the right point and tell me, Imam, I didn't understand. Please repeat this. Okay. See, atoms of an element have a characteristic average mass, which is unique to that element. See, every person, like I must be having some mass, you must be having some mass, and that is unique to me and to you all. Same thing, every atom has a characteristic average mass, which is unique to that element only.
Yeah.
Like I said, potassium has mass of 39, oxygen has 16. If I talk about magnesium, it's 24. So different atoms have different masses.
Yes.
Okay. And the last point of modern atomic theory is atoms of any one element differ in properties from atoms of another element. It means if I talk about atom of oxygen and atom of carbon, they would be different from each other in all the properties. They would not be same.
Okay.
Okay. But if I talk about oxygen atom, suppose wherever you live, the oxygen of that part, and wherever I live, the oxygen of that part, it's same because it is oxygen. It doesn't matter to which place it belongs. Clear?
Yes.
Okay. Now, the first part, which we do in class 11th, is how the electrons were discovered. Okay, beta?
Yes.
So let's study about that. First of all, the electrons were discovered by Mr. J.J. Thomson in 1897. Okay.
Yes.
You can see the diagram as well. He made this setup. This tube, this blue colored tube which he has taken is called as cathode ray tube. That is why this experiment was named as cathode ray experiment. Okay, beta?
Yes.
So in 1897, Mr. J.J. Thomson used a cathode ray tube to deduce the presence of a negatively charged particles, means to detect the presence of a negatively charged particle, means electron. What he did, listen to me very carefully. He took a glass discharge tube. You can see it clearly. Then he put two electrodes inside them. One was anode, one was cathode. He connected to a battery. See, the source of current is high voltage. It was around 10,000 volts. Okay. Okay, beta?
Yes.
Yeah. The current, the potential difference he applied across the batteries was 10,000 volts. Now what he did, he created a vacuum environment inside the glass discharge tube. He removed almost all of the air and left very little air. So the pressure inside the glass discharge tube was 0.0.